Okay. In mathematics, a sequence is what? An ordered list of numbers. So each number in the sequence is known as a term. A finite sequence. Did I spell that right? F-I-N-I, right? Just an E? Yeah, sequence. A finite sequence such as 1, 3, 5, 7, 9, 11 contains a finite number of terms. That means this sequence ends. How many terms does this sequence have? 6 terms. There are 6 numbers in the sequence. That means there are 6 terms in the sequence. All right? An infinite sequence, such as 1, 3, 5, 7, ... contains an infinite number of terms, meaning the sequence will never end. So each term of a sequence is a function of its position. Therefore, an infinite sequence is a function whose domain is a set of natural numbers and can be written as f of 1 equals a1, f of 2 equals a2, f of 3 equals a3, and so forth. So instead of, when we do the equations, instead of them being f of x, our equations are going to be a of n equals. And that's going to denote the nth term. So instead of dealing with x and y, we're going to be dealing with a and a of n. Now, what is n? That's the position that it's at. So this right here, this is the first term. 3 is the second term. 5 is the third term, and so forth. Does that make sense? Okay. Natural numbers. What are natural numbers?
1, 2, 3.
Whole numbers greater than 0. So 0 is not included. Your sequence will always start with the first term. We're not starting at a 0 term. Does that make sense? All right. If the domain of the function is only the first n numbers, the sequence is finite. Because if it's n numbers, that's a specific number of terms it has. So if I said it's the first 5 numbers, it's finite because it ends at 5. Infinitely many sequences exist with the same first few terms. To sufficiently define a unique sequence, a formula for the nth term and other information must be given. For instance, if I give you 1 and then I give you 2 and then I give you 4. Well, maybe not. That's not a good example. Let's not start with 1. If I give you 2 and I give you 4, how do you know if you're adding or multiplying? You don't. You have to have more information, or you have to have something defined explicitly. An explicit formula gives you the nth term a of n as a function of n. So an explicit formula is going to be where you can plug in a number to n and get an answer. Kind of like an equation that we've dealt with all year long. Right? So we're going to find some explicit formulas. I'm going to give you 2, 7, 12, 17. Can you find the next 4 terms in this sequence? What is the next term after 17? 22. How are you getting that? Do you agree everything in this sequence, every single time it's adding 5? So then what's it going to be next? And then. By the way, all of these examples are basically what your first quiz is going to look like. Okay? So can you find the next 4 terms? Also, can you figure out the explicit formula? So an explicit formula is always going to start with a of n equals. If it's adding the same number every time, what is that like as far as equations go? Plus 5, it is a linear equation. Now, we're not doing equations, we're doing sequences. So instead of linear, we call this arithmetic. Now, I agree, arithmetic and arithmetic are spelled the same way. One of them is an adjective, one of them is a verb. Okay, so I agree. I think I said noun last period, but I think I'm wrong about noun. Anyways, arithmetic is what you do. Arithmetic is describing the type of sequence. Okay, so this is an arithmetic sequence, meaning you add on Wednesday next week, we'll go into more detail about arithmetic sequences, but I just need you to know it's linear. So do you agree a linear equation, whatever it adds each time, that's what we do? Okay, when you get to this question on your homework in your quiz, it's purely a guess and check type thing. All right, this is 5, adding 5 each time, so it's 5n. Do you agree 2 is my first term? If I plug in 1, n equals, what is 5 times 1? How do I get to 2? And then you need to check your other terms to make sure it works. For my second term, what's 5 times 2? Minus 3? 5 times 3? Minus 3? So does that work for all of these? Yes. This is the explicit formula. What questions do I have about this problem? Why what? So all we're doing with sequences is finding patterns. Your goal here is to figure out the pattern so you can predict the future. Okay? So find the next formula, the next 4 terms of this sequence. 2, 5, 10, 17. What's going to happen next? Does it add 3 every time? No, what's happening here? So what's it going to add next time?
9.
Plus 9. What is 17 plus 9? Yep. And then? Yep. Plus 13? Perfect. Now, is this arithmetic? Why not? Because it's not adding by the same number. Anybody know what this is? It's not exponential. We'll get to that. Louder? What if I did this? What's happening here? Do you agree it's adding 2 for all of these? That's called a second difference. If it does that, that makes this a word you know. This is a quadratic equation. Alright. If you have a second difference, it's a quadratic equation. There is no special sequence word for quadratic. So my a of n is going to be n squared. And then now we got to test it out. My first term is 2. What is 1 squared? How do I get to 2? And then check it. What is 2 squared? How do I get to 5? 3 squared. Is it working out for all of them? So this is my explicit formula. Could you figure out the 15th term if I asked? Yes. You just plug into n. Okay? Now, what if I give you the explicit formula and I ask you to find the first 4 terms? How are you going to do that? Here. Plug in the numbers. What is a of 1 going to give me? 2 times 1, negative 1 to the 1. It's going to give me negative 2. So 1 is negative 2. My first term is negative 2. A of 2. 2 times 2, negative 1 squared.
Oh, yeah, that'd be
4.
No, what is the equation?
2 times 3, negative 1 to the third. Negative 6. And then 2 times 4, negative 1 to the fourth. So negative 2, 4, negative 6, 8. What is this negative 1 to the n doing? What is this negative 1 to the n doing right here? It's making my signs. Yeah, if you have an odd number, it's going to be negative. If you have an even number, it's going to be. So this right here, it is alternating your sign. Anytime you have negative 1 to the n, its purpose is just to change the sign. Write it down. All right, I want you to do the last one on your own. Go. Oh, by the way, this is the answer. Are we done or we need more time? Nobody's out. Oh, Ava's out. Is that what y'all got? Negative 9, negative 2, 17, and 54. Does that make sense? Alright. First 4 questions on your quiz next Wednesday. Any question for me? Okay, no, we have to do the back of this page and then we're done. We'll do page 1 and 2 today. Alright, this next part is not as easy. So, sequences can also be defined recursively. Recursively defined sequences give one or more of the first few terms, then define the terms following using the previous terms. I'll explain that. The formula defining the nth term of the sequence is called the recursive formula, or the reoccurrence relation. If I'm being honest, we will always call it recursive formula. I think that's the last time I'm going to talk about recurrence relation. However, if you go to a different school and learn more about sequences and series, that professor might call it a recurrence relation. Just know they're the same. Yeah, I spelled that wrong. I don't know why I put an O in there. Okay, recurrence. Okay, a recursive formula requires 3 things. Before that, what does the word recursive mean? To go backwards, exactly. So you are going to have to use the term before it, backwards, in order to find the next one. So you need to know where to start. You need to know an equation and you need to know a domain. Every recursive formula has all three of these things. If you're missing one of them, you don't have the formula. A lot of times, yes.
Gerardo said you spelled recursive wrong.
Goodness gracious, I forgot the C here. Goodness. It is.
Yes, you did. You pointed it out.
It's okay. You're accurate. Thank you for saying something. Is that what you were saying the first time? Oh, I was looking at that one. I don't even know what's happening right now. Hold on though, listen, if you don't have these three things, it's not technically the recursive formula. A lot of y'all just want to put the equation and think that you're done. No. The equation requires, a recursive formula requires a starting point, and it requires a domain. So, I'm going to skip example 2A and do that as the second one. So can everybody open up to the back page? We're learning about, we are, just for a quick step. Alright. It says find the sixth term of this recursively defined sequence. Do you see, y'all quit talking please, how I give you the starting point? I give you an equation and I give you the domain. So, I want which term? So you can't just plug in 6 with a recursive formula. You can only do that with explicit formulas. Recursive formula, you have to find every single term before the 6th term. Well, what's the only thing we know right now? This is the start. We know the first term is 3. How do we find the next term? How do I find that second term? So I'm going to want this. This probably tells me this tells me what to do next. So I need to find the second term. A of 2 is negative 2. Do y'all see how that says A of n minus 1? Carly, you with me still? This right here, what that means is that means the previous term. The previous term. What's the term right in front of the second term? Which is what? 3. So to find A of 2, I'm going to take the term before it times negative 2. What's that? The second term is negative 6. Shh, boys. How do I find A of 3? Negative 2 times, what's the term right in front of this? No, but what's the value? Negative 6. What's negative 2 times negative 6? What is this doing each time? This is just multiplying by negative 2. So what's going to be the next term? And then negative 96. So what's the question asked for? So what is your A of 6? And that's how you would answer this. Could I have figured out the 6th term without knowing the 5th term? Not with this equation. Not just with the equation. I had to have all that information. Yes. Let me finish this. Okay? Now, go back to the front page, that last one I skipped. This equation is a doozy. It's a big one. This time, I want the 5th term. Shh, boys. What did I give you? I'm starting at 1. This one's a little bit more complicated. How do I find the second term? What does this mean right here? The previous term. So what's my previous term here? So 1 plus 2. What's the n value here? The n value. That's my term value. Minus 1. What is 2 times 2? Plus 1 minus 1? 4.
Yeah. That's what I see.
A of 3. Thank you. A of 3. What is my previous term? 4 plus 2. What's my n? 3. And by the way, your n is always the letter that's in the subscript right here. Minus 1. What's 2 times 3? Plus 4 minus 1? Alright, you finish this off on your own. Go. Here you go, Edwin. Good to go, or you can stay. No, it's the number right in front of it. Whatever number's in the blank. No, because these numbers down here are your n. Okay, so do y'all notice a pattern here? Aren't these just the numbers below them squared? So that is my explicit formula. If you can figure out the explicit formula and you're over the recursive, you could totally use it. So what is A then equal for my explicit formula? N squared. But that's not what it wanted to know. What did it want to know? Which is 25. So my answer is A of 5 equals 25. Nope. I got 15 minutes. Bye, guys. Have a good weekend. All right. Why is there a QR code? This QR code is going to take you to this page. You can watch it on your own. We're only going to watch a quick minute of this. No, because it can't record the screen.
Getting the QR code without your phone.
Here you go.
The sequence begins with the numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, and continues indefinitely. Each number is obtained by adding the last 2 digits together. If we were to take a perfect or golden rectangle, break it down into smaller squares based on Fibonacci's sequence, and divide each with an arc, the patterns begin to take shape. We begin to see Fibonacci's spiral. The spiral in and of itself is insignificant. Its importance is revealed in where we find it. Take, for example, the sunflower. The display of its florets are in perfect spirals of 55, 34, and 21. The sequence of Fibonacci. The fruitlets of the pineapple create the same spiral based on the sequence. The pine cone does the same. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers, and especially the nautilus shell are formed with this exact same blueprint. With each segment of growth, the nautilus adds to itself one more value on Fibonacci's scale. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years.
Okay, so Fibonacci's sequence is not something that he sat there and made up himself and was just like, hey, look at this pattern. It was something that he discovered that happens throughout nature, like we just showed you in the video. right? So all of this existed, and he just formalized it using numbers that we understand. The spiral of our DNA has the same sequence as the spiral of the galaxies in space. It's very, very interesting if you really, really go into the depth of Fibonacci's. What we just did is all I'm going into Fibonacci. But you can go way more into it if you would like. Again, it's super, super interesting. So, Fibonacci sequence is described by the many patterns we found in nature. The first 6 terms, y'all, don't be rude, I'm talking. 1, 1, 2, 3, 5, 8, and the sequence is only defined recursively. So somebody asked me first period, Ms. Olivares, why do we even use recursive formulas when I can have an explicit formula? He can't come in, Edwin can come in, but yeah. Because not every formula has an explicit formula. This is a good example of that. So how is Fibonacci sequence made, or how do we continue it to find the 7th through 10th term? So we have the first 6 terms. I want the 7th, 8th, 9th, and 10th term. How are we going to figure this out? Adding the previous 2. 1 plus 1 is 2. 1 plus 2 is 3, and so forth. So what is 5 plus 8? 13. What is 8 plus 13? 13 plus 21? And 21 plus 34. Fibonacci sequence is an infinite sequence. It goes on forever. Like he was saying in the sunflower, scientists were looking at it. They noticed that the numbers 21, 34, 55 kept coming up. And again, these numbers come up all the time in nature when you're measuring different things. So how do we define this recursively? I told you needed 3 things to define something recursively. What do we need? How does Fibonacci sequence start? How do I write that? A of 1 equals 1. But can I just give that to do Fibonacci sequence? No, what do I have to do? I have to give 2 terms, because don't you need 2 terms in order to do it? So what's A of 2? 1 as well. So that's my starting. What's my equation going to be? A of n is going to equal what? What do we do here?
The previous term plus the next.
How did we write the previous term?
A
n minus 1 plus, so instead of a of n plus 1, we could do minus 1. It's the term right before it and the term 2 before it. So a of n minus 2. Does that make sense? So like if I wanted the 9th term, I would have to do the 8th term plus the 7th term. And then what was the last thing we needed to do? The domain. What is the first number we're going to start at? Nope, I gave you 1, I gave you 2. So what are you going to do next in the sequence?
2.
Nope, I already gave you 2. 3. So it's going to be n is greater than or equal to 3. Typically, except Fibonacci, typically you're going to get n is greater than or equal to 2. Because I'm always going to give you the first term and I want you to start at the second term. Alright, last thing we're going to do today, I'm going to do this in about 5 minutes, is end behavior. We learned end behavior before spring break. Do y'all all agree? Okay, and remember how we wrote end behavior as a limit? Does anybody remember what 1 over x looks like? In which quadrants? 1 and 3. Does everybody agree with that? And do you agree it has an asymptote on the x and the y-axis? So as a reminder, end behavior of a function describes how a function behaves at either end of the graph, to the left and to the right. That is, end behavior is what happens to the value as it increases or decreases without bound, becoming greater and greater or more and more negative. So remember, we write it as the limit of f of x as x approaches negative infinity, and the limit of f of x as x approaches positive infinity. Let me zoom into that for y'all. What's happening as this graph goes to the left? Look at your left arrow. What's happening? Say it again. Nope, as it's going to the left, what is it doing? It's getting closer and closer to what? 0 from the bottom. So I write O negative. As it's going to the right, isn't it? As it's going to the right, what's it doing? Going down, but getting closer and closer to 0 from the positive side. This is called converging because it's going to a number. Over here, what if we were to graph this quadratic equation? It's opened up. How does it shift? Right 3 up. And it opens up. We're just doing a sketch, so the 2x is fine. How would I write the limit here? What's happening as x approaches negative infinity, as it goes to the left? What's this arrow doing as it goes to the left? Goes up to infinity. And what happens as it goes to the right, as x is approaching infinity? Still goes to infinity. This is called diverging. When your limits are infinity or negative infinity, it diverges. It's not going to a specific number. The same thing applies for sequences. As the domain of the first function f of x equals 1 over x approaches infinity, the range approaches a unique number called a limit. So in this one, my limit would be 0. However, if you have an infinite sequence, it may also have a limit. If a sequence has a limit, such as the term approaches a unique number, it is said to converge. That is when it goes to a number. If not, it is said to diverge. That is when it goes to infinity or negative infinity. Has anybody heard of the movie line, "The limit does not exist"?
No.
Okay, so that's what kind of this is about. All right, the limit does not exist if it diverges, because it goes on forever. Has anybody ever seen the movies, the Divergent movies? Okay, why are they called divergent? Because it goes into the infinite abyss type thing. Converging means it goes into one. You converge, well, into one number, not necessarily the number 1. So, determine whether A of n, hey y'all, A of n equals negative 3n plus 12 is convergent or divergent. All you got to do is write out the sequence to figure out what it's doing. So I'm going to do 5. You could do 10. You could do 3 on this one isn't really helpful, but we're going to do 5. Let's plug in our n's. What's the first term going to be if I plug in a 1 right there? 9. What's the next term going to be? And then 3. And what's happening each time? Do y'all agree this is subtracting by 3 every time? And I could keep going forever and ever and ever. And if I kept going forever and ever and ever and ever, what would this eventually get me to? Negative infinity. So A of n, the limit of A of m as it approaches infinity is negative infinity. Because it's just going to keep going minus 3, minus 3, minus 3 every time. So instead of writing f of x, we're just writing A of n. So if it goes to negative infinity, does it converge or diverge? This diverges. Or this is divergent. You can write it either way. You can just circle it if you want. Spammers. What about this next one? We're doing this recursively. If A of 1, 2, 3, 4, 5. If A of 1 is 36, what does it want me to do to my previous term? Multiply it by negative 1/2. So what's 36 times negative 1/2? Negative 18. Times negative 1/2? 9. Times negative 1/2? Negative 4.5. Times negative 1/2? 2.25. Times negative 1/2? 1.125. Negative, right? And then what's going to keep happening? Shh, boys. What's going to keep happening as I keep multiplying by 1/2 or dividing by negative 2? It's going to get smaller and smaller and smaller. Is it ever going to hit 0? No. But what is it doing? And this one's actually kind of interesting because it's alternating signs. But it's still going to be approaching 0 from both sides, right? So the limit of A of n, you wouldn't connect them, but yeah. As x approaches infinity equals 0, therefore it is, it doesn't matter. As long as it approaches a number, it's convergent. It doesn't matter what side. No, it could approach 1. Yeah. Like if I made this 3/2 instead of 1/2.
One last study session.
Wait. No, if I would have put a +1 on the end. Does that make sense? Okay.
I gotta pull up more next year, bro. You gonna see
We'll talk about series on Monday.
I'm not even.